We're on bijective, surjective, injective, bijective, yeah? Okay, so state which of the following maps are functions. So say if they're a function first off, and then say are they injective, and then say are they surjective, and give a reason in each case. Explain why function G is bijective. Right, okay. First one, is it injective? Is it a function? Sorry, is it a function? Yeah, there's one arrow leaving all the inputs, right? That's all you need to know about a function. Is it injective? Injective? No, it's not. Why? Because every output has to have at least one input. And look, there's one here with no output or no input, isn't there? Right? So no. Agreed? Is that right? Yeah. Okay, and is it surjective? Is it surjective? As in, I've done that the wrong way around, have I? No, I haven't. Hang on a minute. Surjective is at least once. Right, at least one. Yeah. Yeah. Right, so it's not surjective, and injective is at most one. Yeah, at most one. The reason it's not surjective, the reason it's not injective is because of the single one, isn't it? And the reason it's not surjective is because there's two coming into that one. Isn't that right? At least it's the other way around, is it? Hang on now. So, like I wreck my own head with this. Surjective at least once, injective at most once. So surjective at least one. There's no there, so it's not surjective because of that, and it's not injective because of that one, the two. Right, I think I have it now, do I? Right, okay, so this one is surjective at least once. Yeah, everything is picked at least once. Yes, it's surjective. Right, at most once, everything is picked at most once. Right, so that means it's injective, so that makes it bijective. Bijective, it has to be both. Sorry, and it is a function to start with because there's one line leaving each dot. Okay, so when you're deciding whether it's a function, all you have to do is look at the first one, and injective, surjective, you just look at the second circle. Is that alright? Okay, right, next one, number 2. Do I need to do any, were you okay with these? I'm talking about it, but, right, is it a function, number 1? Is there one arrow leaving all the inputs? Yeah, it's a function. Is it injective? Now you're looking at the outputs. Injective is at most once, right? So that means no two arrows coming in, so it's not injective. Sure it's not? Right, okay. Is it surjective? Right, surjective is at least once. Is it surjective? No, because this one isn't picked at all. Sure it's not? Okay. Explain why it's not bijective, because it's not injective and it's not surjective. Agreed? Are we all okay with that? Anyone want to disagree with me? Because I wreck my own head with this. Right? Of the 3 mapping diagrams below, one is injective, one is surjective, and one is bijective. Right? Connect each map, so connect the word to the map. So this one is at least once. Right, it's at least once, isn't it? Right, it's not at most once because of 2. So this one's at least once. At least once is surjective, isn't it? Right, okay. This one here is at most once, isn't it? Right, so that would make it injective. And this one is exactly once, so that's bijective. Is that right? Are we good with that? Right, okay. Is it a function? Look at the first circle, and the answer is yes, it's a function. Right? Is it injective? You're looking here. Injective at most once. At most once, that means at most once. Right? No, can't, because look, there's 2 arrows coming in here. Right? And surjective is, you look here, at least once. Yes, it is surjective, isn't it? Isn't it? Yeah? So it is surjective. And it's not bijective. The reason it's not bijective is because it's not injective. It has to be both to be bijective. Are we good? Right, okay. Right, just when I had the mapping diagram nailed, we have these. Right, say whether it's a function. So if it's a function, the first numbers are not repeated. Okay, so A is a function. B, if you look at the x's, none of them are repeated. B is a function. C, look at the x's, the 9 is repeated, isn't it? So C is not a function. D, 1, 2, 3, 4, 5 is a function. E, what, minus 1, is a function. The x's aren't repeated. Right, F is a function also. Right, so the only one that's not a function is C, because of the 9493. Right, you can't have that. Is that okay? Right, then we want injective. So injective is at most once. Right, so at most once. So all the y's can only be there once. Isn't that it? At most once. Injective at most once. So that means the y's can only be there once. Right, okay? So first one, the 4 is the y, the 4 is there twice, not injective. Right, B, 2, 3, 4, 5, that's injective. B is injective, isn't it? Right, look at the y's here. 2 is there lots of times, not injective. Right, here, 1, 3, 2, 4, 1. Right, 1 is there twice, isn't it? So it's not injective. So you're looking at the y's. So minus 1, 2, 0, 1, they're all unique, aren't they? So E is injective. Right, and finally 5, 5, 4, 3, 3, 1, 2 minus 1, 1, 2, 0, 3. 3 is repeated, isn't it? The y is repeated, so that means it's not injective. Right, at most once. Are we good? Right, okay. The graph of the function is shown below. Explain why it is both injective and surjective. So if you draw a horizontal line, it'll hit it at least once, which makes it surjective. If you draw a horizontal line, it'll hit it at most once, so it's injective, so that makes it bijective. Right, are we good? Right, okay, number 7. Yeah. Yes. But bijective, it has to be both bijective, has to be both injective and surjective. How would you check out from a list that it's surjective? Surjected is at least once. You can't, right, okay, you can't tell from the list because you don't know what all the outputs are. Okay, so that's why I didn't ask about surjective here, because you can't tell from a list. You need a mapping diagram or you need a graph to decide whether something is surjective. Is that right? Okay, right, next one, number 7. Use a horizontal line test to determine whether it's injective. Injective hits it at most once. Yeah, it's injective. Right. Surjective hits it at least once. Yes, it's surjective. Right. Are we good? Right. Okay. 8. Right. The graph of a function, real goes to real, is shown on the right. What is the range of the graph function? The range are the numbers that actually came out. So the range is the y's that actually came out. It's minus 1 is the lowest y that came out, isn't it? Up to infinity. Would you agree? So it's minus 1 to infinity is the range. The codomain is the possibilities that comes out, right? So possibilities are all the real numbers, all the real numbers. So see the way, that's the codomain. So codomain are all the possible results, and the range is the actual y values that came out, okay? By comparing the codomain and range, explain why it is not surjective. In order for it to be surjective, the codomain and the range, I didn't say this yesterday, the codomain and the range have to be the same. But listen, I wouldn't worry about that. I would just say that's not surjective, because if you draw a horizontal line, it won't hit it surjective at least once. As in, you could draw a horizontal line down here, right, can't you? Right, and it won't hit the graph at all. Do you agree? Right, okay. Use a horizontal, yeah, it's not injective, so not injective, it hits it at most once. So if I draw a horizontal line up here, it'll hit it twice, won't it? Right. Suggest a restriction on the domain. Now, we didn't talk about this yesterday, this is why I'm going through this sum. Suggest a restriction on the domain to make f an injective function. So injective function is, right, injective, it hits it at most once, right, okay? So basically, if you got rid of half the graph, right, okay, so if you just bear with me a sec, okay, so the graph is something like so, okay, right, so in order, we want to make it injective. So that means when you draw a horizontal line, it hits it at most once, right? So all these ones down here are fine. Would you agree? Because they hit it at most once. So at most once is one or less. That's fine. Okay, the ones up here are a problem, aren't they? Right? Because they're hitting it twice, aren't they? So you want to, yeah. So you want to have it so that the graph is, it'll only hit the graph once. So what you do is, you can get rid of half the graph. If you got rid of half the graph, right, okay, if you got rid of half the graph, it would hit it at most once. Would you agree? Okay, so the domain is the x values. So I just want this, they tell me is 3. So I could get rid of half the graph. So if I just said x has to be greater than or equal to 3, that would only give me half the graph. Or alternatively, I could have get rid of the other half of the, or that half of the graph, and left in that half of the graph. Or what would also be an answer, x could be less than or equal to 3, right? So the x value is going up this way, will give you this half of the graph, or the x value is going down that way, will give you that half of the graph, right? But the whole lot gives you not an injective function, right? Is that okay? Does that make sense? Right, okay, next one. It's the same, that's why I want to do it, right? Because they go, the graph of a quadratic function is shown. Is it injective answer? Is it injective? Hits it at most once. Any horizontal line would hit it at most once. Is it injective? No, right? Okay, because the horizontal line will hit it twice down here, right? Is it surjective? That means any horizontal line here has to hit it at surjective at least once. Is it surjective? No, because I can draw all these lines up here, can't I? And they don't hit it at all. So it's not surjective. So it's neither at the moment, right? Okay. Suggest a restriction on the domain. So restriction on the domain is what you put in. So the domain are the x values. So restrict the x values so it makes it injective. So injective means when you draw the horizontal line, it hits it at most once. Okay, so basically we want half the graph, same as before. Okay, so half the graph, I think this is 2. So if I take all the x values, right, greater than or equal to 2, I'll end up with that half of the graph. Would you agree? And if I took all the x values less than or equal to 2, I would end up with the other half of the graph. Both graphs are injective. Okay, is that right? Are we good? Okay, you give either answer, not both. Right, it just said suggest a restriction, so just one. I gave you 2, so you know they're both right. Okay, but you give one. Is that right? Okay, then had you 10? Yeah. Okay, 1 to 10 was it? I'll give you. Right, 1 to 10 is a quadratic, so it goes up and hits at 1 and it turns, so this is 1. It cuts at -2, does it? Right, anyway, it doesn't matter. Right, use a horizontal line to say if it's injective. So injective, any horizontal line hits it at most once. Is it injective? No, because that horizontal line hits it twice. Right, okay, number 2. Is it surjective? So surjective means it hits it at least once. Is it surjective? Does it hit it at least once? Does every single, remember it goes on forever, and it goes on forever that way. Does every single horizontal line hit it at least once? Yeah, it does. Yes, it does. So it is surjective, right? And is the function bijective? No. Why is it not bijective? Because it has to be both, right? And just looking at it, it would hit it exactly once if it was bijective, right? Are we good with those? Right, as I remember, right, it's kind of, sometimes it's head wrecking, right? Okay, I remember the word slim. I don't know if that's any good to you, but that's what I'm doing all the time in my head. So surjective, it hits it at least once. Injective, it hits it at most once. So surjective, least, injective, most. That's the word I remember. That helps me, right? Okay, but whatever helps you, right? Okay, right, on to the next bit, right, is inverse functions. Right, if I have a mapping diagram, right, okay, and I have one goes to 4, and I have, sorry, 1 goes to 4, why should I do that? Right, I have 2 goes somewhere else and 3 goes, so 2 goes to 7, and 3 goes to 10. Okay, there's a function. Okay, so 1 goes to 4, 2 goes to 7, and 3 goes to 10. That's just a function, right? Okay, and I'm going to call that function f. So function is, this is f of x, right? The function f. Okay, and I'm going to tell you what the equation for it is as well. So the rule was 3x plus 1. Okay, we're all okay with that? Yeah? Okay, right. Is there a function, right, that maps 4 to 1, 2 to 7, sorry, what am I doing? 7 to 2, and 10 to 3. Anyone spot anything? What am I looking for? The backwards one, isn't it? Okay, so instead of starting with 1, 2, and 3, what's the function that starts with 4, 7, and 10 and goes to 1, 2, and 3? This is called f inverse, right? And this is how they write it. F with a little -1 on it, right? So it's called f inverse, right? Okay, so f inverse, can we come up with a rule for it? Okay, so how do you come up with the rule for f inverse? Okay, right, so I want to come up with the rule for f inverse. So what I do is, right, okay, is f of x, the original function told me f of x is equal to 3x plus 1, right? Agreed? Right, f of x is another way of saying y equals 3x plus 1. So you know the way this formula here at the moment has y equals. You rearrange it so you have x equal to everything else, right? Okay, so rearrange it so you have x equal, instead of having y equals everything else, rearrange it so you have x equals everything else. So I'm going to bring over the 3x, and I'm going to change the signs as well, right? So if I bring 3x is equal to y minus 1, okay? So I brought over the 3x and changed the signs. Is that right? So that means x is equal to y minus 1 over 3. So instead of having y equals, you now have x equals. What you do then is you replace the x with f inverse of x, f inverse of x. So instead of writing x, write f inverse of x, and over this side, instead of writing y, write x. So the rule to go backwards is, right, and check it out. If you put in a 4, you get 4 minus 1 over 3, which is 1. Put in a 7, you get 7 minus 1 over 3, which is 2. Put in the 10, and you get a 3. Is that okay? So it's like, how do you get the inverse function? When you get the function, it's written as y equals. You rearrange so you have x equals, x on its own equal to everything else. Then you replace the x with an f inverse of x and replace the y with an x. Okay? Right. Right, and you can only get the inverse of a bijective function. Yeah. Right. Another example, harder example. I'm going to call this example 2 because I've just done an example up there. I just didn't put example 1 on it. Okay? Yeah. N is gone, don't be chatting. Right, f of x is equal to 10 minus 2x all over 3. And the question is, find f inverse of x. Right. And then part 2 is show that f after f inverse of x is x. So that means if you put in x into f inverse and then you put it into f, that your answer will just be x. So you get what you started with, which makes sense. If you put in, for example, above, we put in a 1 and got out of 4, right? And then if you put the 4 into the inverse function, you'll get out of 1. So you put in a 1 overall and you got out of 1. That's what they're trying to show there. Okay? Right, let's start with part 1 to find the inverse. So instead of f of x, you let y equal to 10 minus 2x all over 3. Next step, you rearrange so you have, instead of y equal to, you rearrange so you have x equal to everything else. So best thing to do is cross multiply. Y by 3 is 3y. And 1 by 10 minus 2x is 10 minus 2x. Okay, so I want x equals, so rearrange, bring over the 2x, minus 2x, it comes plus 2x equals 10 minus 3y when that comes over. And then divide across by 2, so you get x is equal to 10 minus 3y all over 2. Then replace the x with f inverse of x. So f inverse of x, replace that x with f inverse of x, and over here replace the y with an x. So 10 minus 3x over 2. That's your answer. Okay? Right. Part 2. So I have to get f inverse of x. So remember that's f after f inverse of x. So that means do f inverse of x first, f after f inverse. So when you do f inverse of x, that means into f inverse, everywhere you see an x, put in an x, so you end up with 10 minus 3x all over 2. So then you have to take that answer and put it into f. So into f, you have to put in 10 minus 3x over 2. Right, so where was it? Where's f? Oh yeah, no. So everywhere I see an x, put in a 10 minus 3x all over 2. So the original function was 10 minus 2x over 3. Multiplying out, okay, so on top that would be 10, 2 multiplied by, and the 2 at the bottom cancel, so you're just multiplying in by a minus, that would be minus 10 plus 3x all over 3, and here we'll end up with 3x over 3, and you'll end up with an x. So basically I put in an x into the inverse and then into the function, and I ended up with what I started with. Okay? And that's what your inverse function should do. Right? It's backwards. So you went forwards and then you went backwards and got back to where you started. Is that right? Okay? How am I going for time? 11:36. I'll do one more example. Example 3. Right, so f of x is equal to 4x plus 5. So find f dash of x, or f inverse of x, even f inverse of x. So that's part 1. And part 2, investigate if f inverse f of x equals f times f inverse times x. Right. Okay? So that's f inverse after f. This one is f after f inverse. Okay? Right, part 1. Right? So instead of writing f of x, you write y equals 4x plus 5. We rearrange, so I have x equals, so I get 4x is equal to y minus 5, then divide by 4, you get x is equal to y minus 5 all over 4, and then replace x with f inverse of x, and over this side, instead of the y, write in an x. Okay, alright, straightforward enough. Right, okay, part 2, it says get f inverse f of x, and then on the other side it says get f inverse of x, and it says investigate if you get the same answer. Right, okay, so investigate means you may or may not. Right, okay, so may or may not. Right, so here I have to do f inverse after f of x, so that means I have to do f of x first, which is 4x plus 5. Then I have to do f inverse of the answer, so that means into f inverse, everywhere I see an x, I'm putting a 4x plus 5. So this is here, so I get 4x plus 5 minus 5 all over 4. So instead of that x, I put in a 4x plus 5. Sorting that out, that's 4x over 4, which is just x, which is exactly what I'm supposed to get, because f and f inverse are the opposite of each other. Right, so one takes you forward and the other takes you back to where you started. right? And I started at x, so I should finish at x, right? Here I have to do f inverse of x first, so f inverse of x, I worked it out to be x minus 5 over 4. I then have to take that answer and put it into f, so I have to get f of x minus 5 over 4. So into f, everywhere I see an x, put in an x minus 5 over 4. So it's 4 times x minus 5 over 4 plus 5. 4's cancel, and you're left with x minus 5 plus 5, which is x. And the question was, are they equal? And the answer is yes, they are. Okay? Right, so page 251. Let's do 1 to 11, except um, 9 and 10, because they're the two examples I've just done. So 1 to 11, except 9 and 10, because I just did those as my examples. Okay? Is that right? You want them on the pages? Yeah.